today's lecture is about measurement. So before we talk about measurement in general, we have to recognize that we have three different systems for measuring units. So we say we have three measuring system, three measuring systems here, and we can make a branch here from all those three. The first one called the English system, English measuring system. The second one called the metric measuring system, and the last one called SI system. Now just let me tell you what SI. S means this is international system, and this is called system with the E at the end, and I for international. So it's in French. In the French, they have international system. The French, they say the noun, and then the adjective will come after that. So SI means international system. So international. So let's look what's the difference between those three. And I'll take another page so we don't have to overload those pages. So I will take those measurements here. I'll say this is the English. This is the metric. And this is the SI. Now, and then I'll see what's the difference between all those, where we have to apply those all three systems. So, and I will look at the first, some of the properties, such as the mass, the length, the volume, and time, and then one more maybe will be the pressure. So, and here we'll have those, what are those, the basic units used in each of those, in each of these systems. So English, for the mass, you use LP, which is the pound, the basic unit. The metric, we use what? G, grams, correct? And the SI use kg, kilogram. Okay, so you can see the difference now between them. The length here, we use the metric is meter, correct? That's meter here. And here we use, and the length here you use a mile, or the basic unit use, use not the mile, but FT, the foot. And here is the same thing, is kilometer. I think the or the meter itself. This is correct. It's kilogram, sorry. And this is use, we can use still the meter here. And this is the meter. The volume here, they use the gallon. That's the gallon here. And the metric will use liter, L, liter. And this is use meter cubic meter. So cubic meter. Those are the basic units are used. The time, S, 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 and S is second. So the time in all of them is the basic unit is second. The pressure, this is LP, or they use inch, yeah, pound per square inch. This is pound per square inch, and here use ATM, atmospheric pressure, and 1 ATM is 760 torr. Just to give you there. Here they use uh, kilo, or they use kilopascal or Pascal. We can say Pascal here. Pascal here, the relationship is 1 ATM is 101 kilo Pascal. So from this, you can see the difference between all those three systems. Now, the question is where we have to use English, where we have to use metric, where we have to use SI. Well, it looks like, I'll take another page. It looks like English system, the English system is used mostly on the commercial side, commercial, correct? Or businesses, commercial or economy or whatever. So it's a commercial stuff. So then the metric, the metric one, it's used for scientific community, correct? Here it is. Now, I'll add here community. The metric is outdated, and then the push is towards to have SI is used for scientific community, and it is replacing the metric system. Slowly, but surely. So you see, it's a slow process, and the SI is the whole world is using as unified measuring units in the scientific community. So this will be an unified measuring system used throughout the world. So this one will be remain, and the metric might just disappear, because really the SI is using the metric system. So if I get another page, SI is really using the metric system. Okay, and the metric system, if you look at this, metric system is always based on power of 10, based on power of 10, correct? And the metric system and the SI is adopting this power of 10 system. So SI is adopting the power of 10, correct? And there's always codes involved in the metric system. And these codes, they have to have a value, a power of 10 value. So these codes have to have the power of 10 values. Let's go and look at this. I can just give an example here of those. Those you have to memorize really. We will be using using the following codes in general. So we might use other codes, but we will be using those in general, and you will see them in the quizzes, you will see them in the exams and the final exams. What are those codes? So the codes are small m, correct? Not the meter, but this one here, we call it a milli, correct? So a milli, and that's the code. Let me just go back and say, make a table maybe. This will be good. Let's make a table. I'm sorry. Let's make a table. This is the code, and this is the name, and this is the value. So the code is M, the name is milli, double L-I, and the value 10 minus 3, correct? The other code is C, small, and this is small letter, and this is again small letter, because we are reserving those for something else, correct? You'll see later on the capital letters of those units naming something else, like the capital C, maybe the specific heat, correct? So that's all small letters. And this code is Santi, and 10 to minus 2, correct? And second one is D, called small letter, and called Desi, correct? Desi, and is 10 minus 1. Those are the ones you will be using heavily. And last one we'll be using, you'll be using the K, and this is small K. Okay, so it's small K. This is a kilo, small K, and this is 10 plus 3. Those are the most heavily ones are used, correct? And you will see later on, as I will later on, you will see later on, K, capital K, is used for SI temperature unit, correct? Called capital K, Kelvin. Called what? Kelvin. Capital K, correct? Capital K. Any questions so far? Any questions so far? So capital K is for the Kelvin temperature in the SI system. correct? And the small k for kilo. Those are the ones we'll be using heavily. But if you look the opposite of that, you'll see, if you look at this, uh, for example, we can see the opposite. There are some codes. All those codes are negatives, correct? So this is, those are negative, correct? Negative, negative exponents, correct? Negative exponent. So those are negative exponents. So, but this one here is positive, correct? Exponent. Now, if you look at your book and if you go to the other literature, you will see there's a positive ones too, correct? There's a positive ones as well, not only negative, but there's positive too. So you have, for example, we said D is Daisy, correct? An example here, just I'm not going through this. You can look at this. Daisy, correct? And we said that's the code, and the value of it is what? 10 to minus 1, correct? Are you following? Now, if I go this and so what is the opposite of Daisy? Well, capital D will be Deca. And the value is, what the value is? 10 plus 1. That's the code here. So you will see the codes are switching by switching the exponents. And that's always the case, correct? So, and if you look another example here, if I have M, correct? M is we said milli, correct? 10 to minus 3, the value. And the small k is not the same thing, but is a kilo. This is 10 plus 3. Another example, and then I'll stop here from this, but another example here. Then you have, this is micro. This is 10 to minus 6. And this is capital M, is called mega. Remember? Mega bytes, mega something, mega 10 plus 6. So and so on. So it goes like and this is always the case. So they have a name positive and negative, and you can look at those. You don't have to memorize them, but the ones I gave you in the table, those are the ones are heavily used in our lecture exams and in the labs as well. So, but those are just to look at those. So, any questions so far? Yes.
For the milli and kilo, why is it?
What's that?
Why is for mil and kilo? Why is it RO?
Not the. You mean what? The code's not the name or the value?
The values.
The value is the different. The kilo is always plus 3. The milli is 10 minus 3.
The code for the value. I mean, it says RO. Oh, that's 10.
That's 10. Oh, not RO. Oh, sorry. I'm sorry. Maybe RO. No, that's all those does the opposite to each other. Okay, those are what opposite to each other, and you will see even in the process, the commercial names might take. So here it is, like 10 plus 6, correct? 10 plus 6, we call it mega, correct? And capital M, megabytes, meg. But in the commercial use, the commercial one, the commercial use, what's 10 plus 6 is? Million, correct? Then the same thing, 10 plus 9, and it has a name. It has a name. And the 10 minus 9 has a name, correct? 10 minus 9 is a nano. So 10 plus 9 in the commercial What we call this? What's that? That's a billion, correct? And what we call 10 to minus 9 for us. What we call that for us, for our scientific use. Come on, guys. You know what comes after megabytes? What come out after that? No, capital G. Capital G for what? Thank you. So that's the giga. So, but that's a million. You can see for that's the code here. Capital codes are the positive exponent. Always they have capital alphabets. So that's gigabytes, gigameter, giga pound, giga whatever. Giga means that's the code, which is means 10 plus 9, correct? And lastly, so you don't have to memorize this. This is 10 plus 12. This one is what? Correct. So that's a commercial. So and don't worry about gazillion. Gazillion is not part of the. That's just that's just the people say gazillion, but there's no gazillion. But there is about up to 10 to minus 24, and up to 10 to minus 24. That's we stop. That's the electron. 10 to minus 24 grams, for example. So those are the units plus and minus. The minus exponent will be smaller alphabet. The positive will be the positive will have a capital alphabet. Okay, so take another page. Now I want to go through any question about these systems. Any question about these systems? About the temperature, we'll go next chapter. We'll talk about this the temperature for the next chapter. The temperature is used Fahrenheit. We did not put this one here, just to let you know. Temperature here. Temperature, it has three systems. The metric, use the centigrade Celsius. And this one here use SI, use capital. Remember, this is capital. And this is Kelvin. And the English system uses the capital F Fahrenheit, correct? Now you'll see the difference between them is this one here has a small tiny circle, which is mean grade, Fahrenheit grade. So Fahrenheit degree, that's the anytime you have this in the top of any alphabets means degree. So this one means degree, centigrade. That's the degree, the small tiny circle. That's just means degree. So that's the difference between this, and this will be covered in depth inside the chapter 2, correct? When we talk about the temperature and the heat and the energy itself. So what I want to go now to talk about significant figures. Significant figures. Well, significant figures is very important for us because they're expressing the uncertainty in a value, correct? So they are expressing the uncertainty in a value. So we use them for this as such. So, and they have certain rules. So, they have certain rules. If I have, for example, our balance the balance in our labs has um, has about 300 grams, has maximum load capacity. So now with this one here, 300 grams, this is not an exact whole value, correct? 300 grams is not really true. The manufacturer will tell you. So 300 is an exact, correct? That's an exact whole number. But then the manufacturer will tell you, will tell us at the bottom of the back of the balance itself will uh, will boast at the back of the balance the error of this balance. What's the range of the error? So the range, the back of the range of the error of this balance, and how accurate this is, how precise this balance is. So this one here will give us to the point is how precise is the balance. So then you'll say, well, here it is. I'm telling you, this is, let's have another color. Let's put this color. So maximum load, in the back. So 300 point plus minus 0.5 gram. 300 grams, correct? So here it is 300 grams as well. So the manufacturer is telling us that's not really the balance is all about. The balance has an error in recording this. And so it can be plus minus 0.5. So it can go from half a gram, this is 2,995, to 300.5 grams. So this is the range where the balance is in between. And we use therefore the significant figures to express this uncertain situation with the balance. This is due to many other factors as well. So there is manufacturing, not error, but there's always, you don't have any perfect equipment there. Always it has fluctuation with the pressure, humidity, pressure, room temperature in the lab. So those are the errors. So a half a gram error we can live with, correct? So if you look at this, then let's look at the rules um, of Sig Figs. And the Sig Figs here will depend on the zeros. Believe it or not, is really rules of zeros most of the time. So rules of the zeros. Well, let's look at this. I'll put you a number, might be a little bit very long. And the question is, what is, or how many sig figs is better? How many sig figs does this value below have? That's a question. So I'll write you a long long number, and okay, so here's the decimal. Everybody's following? So the decimal is here. Now we have to determine how many significant figure does this value have. So, well, it looks like, if you look at the whole thing, the zeros, correct? Zeros before the decimal are called decorating zeros. Just for decoration, they have no value, no significance whatsoever. So those zeros here, that's rule number one. So number one, zeros before the decimal are called decorating zeros, and they are not significant. Okay, so now zeros is number two. Zeros after the decimal, if in the presence of zeros decorating zeros, they're called locating zeros. They locate the decimal. They are not significant. So in present of the decorating zeros, zeros after decimal are called locating zeros, and they are what? Not significant. Correct? So that's good said and done. Let's look at those zeros trapped between whole number, between exact numbers. Those are always significant. Correct? So in rule number three, zeros trapped between whole exact numbers are always what, guys? Significant. Correct. Thank you. How about those zeros? Those are tricky here. Number four. Correct? Zeros coming after whole number with the presence of the decimal coming after exact number, but there is a decimal there, they are always significant. Correct? But if there are no decimal, they are not significant. Correct? So let's look at this. Zeros, we will do some examples. Zeros coming after, see, after exact numbers in the presence of decimal are always what? Significant. Correct? How about whole numbers here? How about let's take this one here. How about this and this? Those are exact numbers, are always what? significant, are always what? Significant. Now, we said the decorative one, the decorating zeros, not significant. The other one after the decimal, with the presence of the decorating one, called the locating ones, they are not significant. The trap zero in between, they are significant. The zeros coming after exact number, whole number, with the presence of the decimal, that's a condition, correct? Those are significant. So now we can we answer the question, how many significant figures does this value have? Can we? Let's start. So the first two zeros are significant. That's two. Then the three numbers, whole numbers, correct? The three whole numbers are significant. So those five. The trap the zeros in between the whole numbers are four, correct? Significant. So we have 2 and 3, 5, 5 and 4, 9, correct? And then the whole number, the whole numbers, it's 3, correct? 9 and 3, how many? So how many now? How many? Count them, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, correct? Let me do with this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have only 12 significant figures, and therefore the value will have 12 sig figs, correct? So here it is. So answer, the value does have 12 sig figs. Okay, so now let's go. I want to share with you some significant figure. See if you can take our snapshot here camera. That's a very nice camera we have. That's full screen. Now we need the camera. Where is the camera? Here. Let's see. I'm just looking for the camera. So yeah, I think the camera is. We have to take a snapshot, but so if I take the snapshot of this here, those are the questions. I want to take some of them, but for some reason the camera is not there. Let me see if we can. That's the view. Yeah, just bear with me just to see where the camera is. The shortcut is, well, then let's have yeah, I don't know where the camera is, so let's look some of those, and then just I'll copy and paste those. Here it is, 1, 2, 3, 4, and 0.0023. So let's look at those examples here, and we'll take some examples here. Okay, so determine the sig figs of the following values. So 1, 2, 3, 4. How many significant figures? 4. That's correct. So let me go just 0.0238, and we will do a couple of those. Okay, so I did. Yeah, I don't know where the camera is. Trying to get the camera, but I don't want to. Anyway, so here it is. This is, those are the questions are here, and you can see all those questions are here, and we have most of them here. So I'll take just 5, and you can go and look at the at those problems here. So what's the second one? The second one is 3. Everybody agrees? That's correct. How about the third one? 5. That's correct. Those are the beginning. The 3 ones are what? Those are for decoration. They're called decorating. Correct. Correct. So how about this? The fourth one. What's that? 2 or 4? Do we have a decimal? If we don't have the decimal, that's just 2. If we do have a decimal, then we have. So how much is the third one? The fifth one? 3. Correct. So this is the exponent is not significant. Correct. And here, no decimal. So if I go here and I say I have 1100, and then I put the decimal here, and then 1100, and put the 0 here. So now what we are talking. So in this, we have a decimal here, correct? That's a decimal. So here we have how many? 4. That's correct. If I don't have the decimal present, then it's just 2. The zeros are not significant. Now the zeros are significant here, correct? How about the number 7? How many? 3? No. 5. Because you have a decimal. Anytime you have a decimal, the whole number, they are regarded the zeros after the decimal is controlled by the whole exact number, the 1. Correct? Everybody's following? So that's the difference between those. Any question about those? What's that? Number 5? Number 5 means if I have a whole number, okay, without the decimal, suppose now, let's take 8, number 8. This 8. If I have, so I took the decimal out. So how much I have here? How much? 2. Everybody's following? See the difference between all those? If I have the taken the decimal is a condition. It's a requirement condition. You have to have, in order to have the 0 significant, you have to have the decimal. But if I have, here it is, number 9. Here it is, 0, 0, 0, correct? And then 1, 1, 0, 0. How much is that? 4. Why is 4? They came after the exact number, but that's not sufficient. You have to have the decimal there, correct? So therefore will be 4. Make sense? Now, required condition, you have to have the decimal there. And if there is no decimal, then what? Then there will be not significant. All those the same number, the same values, but different way of expressing it. Now let's look at this. I mean, it looks strange, but if I put this one here, what's the value here? What's that? We have to open an auction here, guys. No, 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 no auction. What's that? Two, three, four. I heard something. I heard something. Zero. Why? Those are what? Those are locating. Yes, thank you. And those are correct. It's just if I take their values, you have to know all those rules of the zeros. So it's not really difficult, but there's a little bit it's tricky a little bit. But that's zero here because now if I have the same value here, just for the fun of this value here, our extended here, I put like sit this. How many now we have? One. Thank you. Now we got that. That we got that. So any other questions you have? Those are yes. Number five. Yeah, number five. Number five, if you have that's the decimal here. That's the decimal. You look at this. Any power, you just ignore it, correct? Yeah. Any exponent there, ignore it. And then when we come to the last chapters, we'll talk about the pH and the logarithm, a little bit different rules. I don't want to confuse you now, but we'll look at the significant figures for the logarithm. That will come later on with the pH. But at least for now, any exponent has no significance. We are not counting there. So that's the reason. Everybody? Okay? So let's look at when we are there, so let's look at the applications, sorry, applications of the significant figures in the mathematical operations. So we'll do the applications. Applications. Let me take this one here out. Yeah. Applications of Sig Figs in application of Sig Figs in mathematical operations. So we'll start with the division and multiplications. So you will do all your stuff here, your calculations with your what? With your calculator, normal calculator, correct? So do all mathematical operations using the calculator. So that's normal. Then here is the application here. When rounding off the answer, when rounding off the final answer, the not in between, the final. Don't do in between rounding. That will give you an error. Just keep tracking the whole thing and see at the end what will be the final answer. So then apply the rule of division and multiplication of Sig Figs. So what it means the answer will be rounded off to the least Sig Figs value. So Sig Figs value correct? So we round the whole thing to the least significant figure. So if I have an example here, let's put an example here. And if I have 3.11 multiplied by 1.4 divided by 3.553 multiplied by 6.821. So I have this operation here. Now let me just share with you. There is a website. I will be using it on and off every time. And this website is, let me just plug it here. I'm using all the time this type of calculator. You can download. I'm not advertising for the company. The company is electrical engineering company. Electrical engineering company. You can download it to your desktop, to your laptop, to your iPad, to everywhere. Except that the phone they charge. Everything free except the phone. That's about $25 for the phone, but you don't need it for the phone. It's scientific, and this is very good one. Why? I can show you why. So if you have no time to go through all these conversions, remember there's a sidebar here at the bottom. You can see it. If I click on it, here we are. So then you have all this, all this whatever, all the units are done. So that's the length, that's the time, that's the power, that's the light, that's temperature, energy, mass, volume, and so on. So you can use any number of from metric to English and SI. So for example, we talked about temperature, correct? An example here. What is the body temperature? You think the body normal temperature? 37. That's, I will go for it. That's centigrade Celsius, correct? So 37 centigrade Celsius is what? Is how many Fahrenheit? 98.6 Fahrenheit. How many Kelvin? 310. That's SI. The other one, the Rankine, we don't use it. Don't worry about it. That's engineering type. But we use up to this, and this. Correct? So that will give you the whole thing. So because of this, we don't add this in the final exam or quizzes, because then the students will download it to their phone, whatever, and then they can cheat in your calculator. The advanced one, the HP whatever, or TI HP 85 or something, those have this program as well, the conversion. So therefore you can just plug in and then you get the answer, correct? So but they give you in the three systems. And the same thing with the length. Somebody will tell me about the length. How much is the the inch? 1 inch. How many centimeters? Somebody worked as a carpenter one day in the life? No. How much? 1 inch. How many centimeters? Yeah, 3. But exact how much? 2.54. Correct. So let's put 1 inch here. Here we are. We have the metric is 2.54, which is the same thing adopted by the SI. So it's a good calculator. I'm not making an advertisement. I'm not getting anything in my pocket, just for liability. So now I'm not interested in this. I'm just close it, and I'll give you the website. The website is eeweb.com, and then you go to the toolbox here, eeweb.com, and then you go to toolbox on the top. See the top toolbox? Click on the toolbox, and I have a lot. They go to calculator. They have even a basic one. I use the basic one, but you can't use basic one for a lot of. They have no log, nothing. Very basic. It's like you go to Walmart to buy it for $6. But the scientific one, the one you use. If I click on it, it will bring me back to this. See? Now let's do our calculations here. We have 3.11 multiplied by 1.4. I'll show you how to enter this. The same thing in your calculator. This calculator uses C++ language. I mean your TI or HP. So I'll put parentheses. So we said what? 3.11 multiplied by 1.4, and then close, and then divide, and then open the other second operation. And what's the value here? 3.553 multiplied by 6821. Somebody has it? Okay, so let's see. Go back, and 3.553 multiply by what? 3, 6 or 3? 6. Okay, 6.821. Close this, and the answer. Here's the answer. I copy the whole answer, copy, and then I go to my iCollege here, I mean my Symposium here, Smart Board, and then here it is. That's my answer. I write the answer as whole, as is. So this is my answer. Now, when it comes to this, I have to get the correct answer, though that's not the whole answer. I have to go and look at, this is 2 Sig Figs, correct? This one has how many? 3 Sig Figs. This one how many? 4 Sig Figs, correct? This one how many? 4 Sig Figs. Which one will win? The 2. That's the least one. That's the least. So here it is. This is the least. Okay? This is the one will win. So if I have this, then I will say I want to make out of this 1.79657423744728 I have to make 2 Sig Figs. Okay? So from this one here, I have to make this, I have to go through scientific. I can use scientific notation if I have to. I'll show you later on what scientific notation. But how to make out of this? Well, I'll cut it to this way. This is my 2, correct? 2 significant figures, 0 and 1, 7. Then I have to look at this and look at the value here. It's 5 and above will be considered as 1. If this value 5 and above, and the previous value before it, the value before it will be rounded as 1. The value before it will be increased by 1. Increased by 1. So the answer is what? 0.18. This is 2 Sig Figs. Make sense? So now let's look at the other rule, which is when we have this addition and subtraction. So let's do this. So addition and subtraction. So you do the same thing. Do all calculations using your calculator. Using your calculator. So there is a free of charge calculator, and this is scientific, the one scientific. Posted on the website, posted called EE Web. So the link is, you don't have to do www, but this is eeweb.com. This is the link, and then go to toolbox, and then choose from there. From there, choose the scientific calculator, not the basic one. Scientific calculator, and it's free. Free download. It's free download. So you can have this. I have it in all my laptops and desktops, so for free. I use I even ignored now. I don't use my one given to me by the college. I have no use for it because that's very handy to use it inside the web. So anyway, so then after you have the whole answer, the whole addition and subtraction, what we have to do? Then we have to apply the rule of these significant figures. So number two, when rounding the final, I'm putting this in a box, not in between. We don't do any in between rounding off because that will give you a big error. Always keep just let the calculator calculate the whole operations. At the final answer, then you apply your rounding off. We're rounding off the final answer. Then the value with the with the least what? Not significant figure this time. Least digits after decimal will control the outcome of the results. Correct? So maybe if I put anything here, no. Okay, so let's look at some examples here. I put you some of those examples here somewhere. Um, I think is here. If you look at some of those examples here, subtraction. Here, this I put some of the examples here for you. See here. Okay, so all those here you can see, and the answers, they have the answers here. And if you are interested, I can upload those inside the iCollege. Yeah, I can upload those are saved. I saved them from the web, correct? So let's take one of those and then see what will happen. Just a simple one, and see what will happen. An example. Let's do an example here. Let's do one example, simple example. So we'll do addition, but it's the same thing for subtraction. So addition. So if I have 3.413 plus, that's plus, correct? And 2.1 and 5.2114, and I'm adding this together, correct? I'm adding those together. So when adding this, the answer will be answer, just a simple answer. This is 4, correct? This is 1. This is 4. 4 plus 1, 5. 5 plus 2, 7, correct? And 3 plus 2, 5. 5 plus 5, 10. Correct me if I'm wrong. That's correct answer? Correct? Then I come here, and this is the decimal. This is my decimal, correct? So how many digits here? I said there are 3 digits, correct? How many digits here? 1 digit, correct? How many digits we have here? 4 digits. So the winner will be with the least digit. So will be 1 digit. So then my answer is will be answer 10.7. Correct? Am I correct, or this is 7 and this is 411. This is am I correct or not? No? Then correct me. So here it is. The best thing is
7, 2,
here. So 4, I know it's the answer is not correct because we did, this is 4, 1, 1, and then 4, correct? So the 4 will come here. The 3 and 4, correct? Correct. 4 and 2. And then what here? 7. and 10. Is this correct now?
Yes.
Okay, so, but the answer is correct at the end.
Final is correct.
Correct? So, then one digit. Now, let me show you a trick here. Um, if I have similar question like this, and have only exact number, and that's you have to watch for. That's you have to watch for. So, here it is. Take another page, and I'll put 3.411, and this is 0, 1, and this is 1, 5. So what's the answer here? 1, 1, 5, 8, 2. Correct? Everybody agrees? That's the answer. Now, what is my final answer though? Well, I said this is how many digits? 3 digits, correct? And this is how many? 2 digits. Well, I'm stuck here. How many digits? How many digits? Zero. 0 digit. So which one will win? The 0. That's the least. So this is the least. So I have a my answer has to come with 0 digits. So what's the answer is? 29. That's correct. You have to watch the digits here. We are not going by the significant figures here. Significant figure, we have division and multiplication. Then we can go through this. Any questions so far? Before we go further, I want just to go and look at the scientific notation just shortly here. Scientific notation is a very good. Scientific notation is very good to determine the to shrink or to expand the value. That's we use it for. So is used to shrink or expand a value, and it's very important in significant figures, in Sig Figs calculations. Correct? So, and if I look at this, I have, for example, 55. Correct? I want to expand this one here and expand it. Correct? I expand 55. I want to expand it here. This value. This value has how many digits? 2 digits. Correct? So I want to make out of it maybe another 5 digits. 2, 5 digits, or 10 digits value. So make it 10. Let's make it 10 or 11, whatever number. So 10-digit value. So in order to expand, there is no way. I have to add what? Zeros, correct? So expansion here will not be available. You have to add zeros to accommodate 10-digit value. So 5, 5, 2 digits, correct? Then 3, 4, 5, 6, 7, 8, 9, 10. Correct me if I'm wrong with the zeros, correct? So I added how many zeros? How many? 8 zeros, correct? So then I'll say multiply by, and I use the scientific notation. How many I added? 8, correct? I added. So then I have here, correct? Then going to the to the right, the exponent will be negative. So going or expansion to the right. So exponent is negative, and its value its values is the number of the zeros. So the number of zeros is 8. So it's, but I'm going to the right of the value, correct? If I go to the left, to the right of the value, correct? To the right of value. So if I go to the right, it has to be negative. And the number I add, so I expanded from 2 digits to 10, correct? Now, how about I tell you now, let's reduce this one here to 1 significant figure. Okay, so I have, now I'm shrinking, correct? From 55, everybody's following? Then that's 2 digits. I want to make just only 1 digit. So if I reduce, that's shrinking, correct? I'm shrinking, not expand. So shrinking,